In this question, we have to evaluate minus a to a square root of a minus x upon a plus x dx. Now rationalization. On rationalization, what we are getting? Minus a to a square root of a minus x upon a plus x, a minus x upon a minus x dx. Now this implies to minus a to a minus x, a square minus x square dx. Now this can be written as minus a to a dx upon a square minus x square minus a to a x dx upon square root of a square minus x square. Now this becomes a minus a to a dx upon square root of a square minus x square minus a to a x dx upon square root of a square minus x square. Now ai1 minus I2. Now I1 is equal to integration of minus a to a dx upon square root of a square minus x square. I1 is equal to sin inverse x upon a with the limits minus a to a. Now I1 becomes, I1 is equal to sin inverse 1 minus sin inverse minus 1. This is equal to pi by 2 minus pi by 2, and this is equal to pi. I1 is equal to pi. One thing. Now going for I2. I2 is equal to minus a to a x dx upon square root for a square minus x square. I2. Now fx is equal to, let fx is equal to x upon square root of a square minus x square, and f minus x is equal to minus x upon square root of a square minus x square. Now, f minus x is equal to minus x upon square root of a square minus x square. Now here what we are getting? This implies f minus x is equal to minus fx. Therefore fx is an odd function. When it is an odd function, then when it is an odd function, what we can write it? Minus a to a x dx upon square root of a square minus x square is equal to 0, and what we are using here? Minus a to a fx dx is equal to 0 when fx is an odd function. This is a property which we have already done it. Okay. So, therefore, I2 is equal to 0. Now, I1 a pi minus 0 is equal to a pi. Hence, minus a to a minus x upon a plus x dx is equal to a pi. Answer.